Okay, today we're going to be talking about factoring trinomials that had a leading coefficient of 1. And remember, when we're factoring, we're looking to get things that uh, we're rewriting expressions into multiplication form. That's what it means to be a factor, and that's what it means to factor. So let's take a look at this easy trinomial to factor. As soon as I know I've got a leading coefficient of 1 right here, all I need to do is put my variables in my bracket or my parentheses, or corrals if you will, and find out factors of 30 that add up to 11. Well, 30 and 1, no. 15 and 2, no. 10 and 3, no. How about 6 and 5? Good, 6 and 5 will work. So now these two need to be plus signs so that they add up to 11 right here. And you have completely factored this trinomial. Take a look at another one. Here we've got a leading coefficient of 1. So I'm going to write my parentheses, put in my variables, and then find factors of negative 24 that add up to 2. Well, let's see here. We've got 24 and 1, 12 and 2, 8 and 3, 6 and 4. Let's see, these will get you to 25 or 23, 14 or 10, 5 or 11. This will get you to 10 or 2. So let's go ahead and use 6 and 4. And for them to add up to positive 2, 6 has to be positive, and then 4 has to be negative. And remember, positive times a negative is going to equal this negative, which we need. This is completely factored. Take a look at another one. Leading coefficient is 1. So I'm going to go ahead and write my parentheses and my variables. Find out factors of 10 that add up to negative 7. Again, that's positive 10 to negative 7. So 10 and 1, 2 and 5. Let's see, 2 and 5 will get to 7. Remember, they both need to be negative to add up to negative 7, and they both need to be negative, so when you multiply them together, they become positive 10. That one's completely factored. How about this one? Leading coefficient is 1. Put in my variable and find out some factors of negative 54. Well, let's see here. 54 and 1, 2 and 27. That's not going to work. How about 3 and 18? That's not going to work. How about, let's see, let's think of some other ones here. How about 9 and 6? 9 and 6 will get us to 3. So let's watch our signs. This has to be a positive 9, so when you add negative 6 to it, you get positive 3. And remember, positive 9 times negative 6 is going to equal negative 54. A couple more examples. Put your parentheses down. Leading coefficient is 1. Put your variables. I think this might be an easy one, 5 and 4. Positive 1b, so that's going to be a positive 5 and a negative 4. And remember, they have to multiply it to negative 20, and they did. Last one. Leading coefficient is 1. And let's find some factors of 41 that add up to 6. Let's see here. 41 and 1. How about, see, that's not an even number, so 2 will not go into it. And if you add the digits of 4 plus 1, that's going to equal 5. So 3 won't go into it. 9 will not go into it. So we've eliminated 1, 2, 3. 4 will not go into it because it's an odd number. These have all been 5 will not go into it because it doesn't end in 0 or 5. 6 will not go into it because it's not an even number. How about 7? 7 goes into 41. Let's see, that's going to go in there. Doesn't go in there. 17 doesn't go in there. So after a while, if you can't find a factor that goes into 41 evenly, chances are real good non-factorable. This is a rare occurrence, but it does happen. So at least you tried to factor this, but you couldn't find out any factors after exhausting, 1, 2, 3, 4, 5, 6, and 7. Chances are real good that you're not going to find very many or any factors of 41. Probably because 41 is a prime number. That's it for the easy factoring for trinomials that have a coefficient that is 1. The next video will talk about how you will be able to factor trinomials that have a leading coefficient that is not 1. See you then.